Hello guys, welcome to my channel. This is Uday Pandit and you are watching MEP Technical World. In this video, we'll learn about basically how to calculate the cable size considering the short circuit current. Okay, so in previous video, we have already discussed about how to select or how to calculate the cable considering the voltage drop and ampacity method, means current carrying capacity method. Even we consider derating factor as well. So in this video we will also consider the short circuit current. If it is satisfied, then we go for cable size, finalize the cable. Okay, so we have to consider these three factors before finalize the cable size. So before start the session, I would like to request you, if you are not yet subscribe my channel, please subscribe my channel and also hit the bell icon so you will get notification regarding my upcoming videos. So let's get started. So basically, what is short circuit current? So generally what happen, so let's consider three phase. Here we have a R, Y, B and one neutral and one even earthing. Suppose this is R, Y, B and neutral even earthing. So basically short circuit current is the fault current, we can say. So when the phase or line to line short to each other, that means it is line to line fault current, or we can say short circuit current. Similarly, between line and neutral, even we can say line to neutral fault current, even line to earthing fault current. So these all are the basically fault current, or we can say short circuit current. So this current is too much as compared to rated current. So during the selection of the cable, we need to consider this cable, whether it will withstand or not for certain time of period. Like this depends upon the breaker. Suppose this is the breaker. Okay, its capacity is suppose 32 ampere TP and its breaking capacity we can say 16 kA and fault clearing time is suppose 0.6 second. Okay, and then load is connected over here, so here is load. Okay, now this is the cable. So while selecting the cables, so this cable we cannot only select or finalize the cable as per the current carrying capacity, even voltage drop. We have to consider the short circuit current as well. So as per this connected load, or as per this MCB rating of short circuit or breaking capacity rating, this cable can withstand or not. Suppose we selected under the breaking capacity of this breaker. At that condition, what happened during the fault? So this cable will be burned. Okay, that's why we need to consider the short circuit current as well. If we are going to finalize the cable of any feeder or any outgoing, then we must have to sure whether it will withstand the short circuit current or not for certain time period as per the breaking capacity of the circuit breaker. Okay, so here we have a formula for calculating the basically how to calculate the short circuit current. So here we have a formula. So A equal to ISH square root T and divided by K. So where A is actually cross sectional area of the cable and IS is the actually short circuit current, or you can say fault current, and square root T is the duration of time, means tripping time of the breaker, fault clearing time we can say, tripping time we can simply say tripping time of the breaker, and K is the constant of the cable, K factor. So here we are going to calculate the short circuit current. That's why let's make it short circuit current. So this is the short circuit current, and A is the cross sectional area, K is the constant, and divided by square root T. So this is the formula for short circuit current calculation. Now here, as I have already told you, so here A is cross sectional area of the cable, and then Is is the short circuit current, which will be in kiloampere, and T is the duration of the short circuit in second. That means also tripping duration, tripping time of the MCB or any circuit breaker, and then K is the cable constant factor. So here we have a, as per manufacturer of the cable, so there are basically two types of the cable as per insulation, XLP and PVC, and as per conductor materials, copper and aluminum. So in case of we have a cable like a XLPE, and we have a cable copper, then we have to consider the, we have to take the K factor value 144, and if we have a aluminum cable then 94. Similarly for PVC insulation, if we have a copper then 109, then if we have a aluminum then we have to consider the 75.8. So it can be taken from cable manufacturer, whether we can get it from Polycab, Phenolax, and another is T means breaker, tripping time we can say. So for circuit breakers, generally for all curves we consider like 40 to 60 millisecond, even we can consider 1 second also. Okay, now let's take an example. So this is the MDB, main DB distribution board, where we have a circuit breaker which have rating 500 ampere, and its breaking capacity is 36 kilo ampere. Okay, now we have already calculated the cable size over here. So this is 1 done 4 core 240 square mm copper XLP armored cable. Now what we have to do, we have to check the short circuit current, whether this cable can withstand this much of current or not, for suppose 0.6 second or 1 second. This we have to make sure before finalize the cable size. Okay, now let's calculate the short circuit current as per this cable size 240 square mm. So here this is the cable, so area is 240 square mm, then T is 0.6 second, here we have considered, then K is 144 because of chart where copper cable and XLP insulation, so this is the K factor value. Then as per formula, so this is the short circuit current, A into K divided by square root T. So now let's put the value. So A is 240, that's why A is 240, then K is 144 divided by T means breaking time, tripping time of the breakers, which is 0.6 second. Then if we calculate this, it will become like 34,560 divided by 0.77, and finally it will become 44,883.12 ampere. This is in ampere. Now short circuit current is in kiloampere, so let's divide it by 1000, so it will become 44.88 kA. So this is our calculated short circuit current as per this cable. Now let's compare this calculated short circuit current with MCB, means circuit breaker, which is MCCB breaking capacity. So here our breaking capacity of this much 500 ampere breaker is 36 kA. Okay, now our calculated is 44.88. so when we finalize the cable, we always consider our calculated value should be, our calculated short circuit value of the current should be always greater than the breaking capacity of the circuit breaker of particular feeder. Okay, as you can see over here, so this is 44 and this is 36, so which is calculated short circuit current of the 240 square mm cable. Short circuit current is 44.88 kA, which is greater than this breaking capacity, which is 36. So hence this cable size is satisfied, so we can go for this much of cable size. So this particular feeder or incomer, if it is below than this, what we can do, so we can go for higher than this cable size. We have to increase the cable size more than 240 square m. That's why we have to check the each parameter before finalize the cable size. Like in previous video we have already considered, while calculating the, we cannot calculate as per the calculated full load current. So we have a factor like derating factor, then voltage drop calculation as per the distance we have to consider. So you cannot go for alone like a full load current, then we have to short circuit current. So this much of parameter we have to consider. We have to make sure is this satisfying or not, this cable size. So hope you guys understand about basically how to calculate the cable size considering the short circuit current. Thank you for watching this video. Please like, share, comments and subscribe, and also hit the bell icon so you'll get notification regarding my upcoming videos. Thank you very much. See you again in next video.